stream them there by accident. Alright. Let's kill this. I may actually kill the screen though, because I'm about to go start doing C++. And that's probably going to be a long and painful process. I don't even think my IDE is set up right. I gotta... Maybe maybe tonight I get like my environment set up so that I can get IntelliSense properly in C++ projects, and then I implement like a little Hello World style async C++ wrapper. Okay, let's see. My heart quakes at the thought of having to re-implement this octree for a third time in a programming language that I'm not good at. But I think that it's like basically gonna be the answer to all the performance issues that we just saw. I'm not sure what type of object I should make. This is all gonna be anybody who wants to watch this is gonna be very bored in the next few hours, because I'm gonna be just fucking trying to muddle my way through this. Let me go look at something. There was a tutorial I looked at a while ago. Async UE52. Async UE52. Async code in UE52. Perfect. Alright, so I got this. There was some... Hold up, before I do this, are there any plugins for async stuff? Ooh. No, no, no. Let's try this. Maybe I'm like pulling my hair out over nothing here, because if I can just use async in here. You kidding me? Oh my god. Make an article about doing async. Don't say how to return the data from it. Okay. This was the best video I saw on it yesterday, I think, that I'd seen.
Sporadic series that I'll be adding to every now and then. I know I said last time that I was taking 3 weeks off, but I hope that this is a short video to produce and I'll be able to crank it out in a few days. I often include little amuse-bouche pieces of advice that I stumble upon in my devlogs, and I think it'd be worth branching that off into its own series. Hell, it would make my own life a lot easier, so I could reference them more quickly instead of having to look through all of my scripts. So this series is going to be exactly that. This is episode 1 of Indie to Indie, the series in which I'll go through some practical advice for game dev that I've discovered while doing game dev myself. This is going to be...
So I may not have to reproduce the entire awk tree. I think what I need to do is pass the node.
This pilot episode is going to be one for the programmers.
The
asynchronous
points to insert and like the data specifically for the insert function, and then have that return in altered node and just swap the whole tree up.
Helping hands so you don't have to repeat the same slog that I did. Asynchronous code is sort of like quaternions. Most of the time you don't need to know them, but when you do, you really do. Let's keep one thing in mind. We're game devs, so that means we have to keep frame rate high enough to be playable and, more importantly, enjoyable. So, if you ever have code that is very computationally heavy, custom pathfinding in my case, asynchronous code allows you to run all that stuff on a different thread so that way your game's frame rate doesn't tank. This video applies to both UE4 and 5, but I don't have Unreal Engine 5 installed, so I'm sticking with UE4. I've created a demo project to go over a basic example of how to write asynchronous C++ that I will iterate upon by adding more robust behavior and functionality. And I do mean C++. While you can set timers and blueprints, you cannot node your way to truly asynchronous code. And since this is a programming episode, I'm going to upload the project with the code to a GitHub repo. Check the description for the link. Asynchronous code and multi-threading is basically diving straight into the deep end for programming. So if you're unfamiliar with C++, you might want to tap the brakes. As I said, just like with quaternions, you can get around a lack of technical knowledge with creativity and elbow grease. So, with that disclaimer,
you just have to face mesh on it.
The good stuff. The easiest, aka best for indies, way to write.
You sit there, you bash your face on the keyboard until it works.
Use the fruntable class, and if we look at the docs, we can see they're very good. So, I've already written all the example code step by step, and the first step is this: just a class.
All right, hold up. Alright, so before I progress further, I'm going to have to make sure that the dev environment is set up properly, because I've always had problems with this with like IntelliSense and shit ever since I tried to do it the first time. So that means I need to spend a little bit of time just setting the environment up so that I can properly get IntelliSense on C++ files. I literally just want to get this guy's demos running before I do anything, because writing the Octree insert code is going to be way more complicated than any of this by like a lot. So I'm going to make sure that I understand the basics of how this async shit's working in UE5 before I try implementing the giant fucking nasty insert method. All right. Hello. I realize this is boring for people to watch. It's going to be boring for a while today because I have to figure out a way to perform bulk Octree inserts asynchronously, because it's an expensive function. I can do about one every 0.02 seconds and not have it impact the game performance with the way it's set up right now, but I need to be able to do like tens of thousands of them, so it's not super incredibly viable as far as speed goes. And that means the answer becomes async code, and to do that, I'm not really a pro C++ programmer. I've done a lot of C#. I've wrote some C kernels for some CUDA stuff, GPU multi-threading stuff before, but that was a long time ago. And so you have the complexity of the algorithm itself, which is not trivial, and then layer that on top of the difficulty of doing it in a language you're not super familiar with. So I'm gonna be bashing face on this probably all weekend, but all right. So I need to make these f runnable h CPP, and like I'm not sure like what the best pipeline is for creating these things either. Can I just add new Okay. So let's take a look. Include runnable step 1H. I'm just looking at his setup here. Okay. Guessing the includes in the CPP file. Yes. So here's my header. I got it. It's in my brain I was thinking header should go on the left and implementation on the right, and so it was like confusing me, but this is definitely the header. So include core minimal how runnable H. Man, hang on. I'm not particularly interested in repeating work here. I want to plug it all in myself. Like, so I don't want to just copy the whole project, because then I won't, like, I'm gonna make each file, but I don't need to do the actual typing. Like, I just need to see what goes in the file, and when I do that, hey man, my IntelliSense is working now. It wasn't working the last time I tried to do this. I wonder if I fixed it or something. Bullshit. Bullshit, yeah? No. Oh, God. Okay, fine. This was also a recent tutorial, which is nice. Okay. Blab. And that. So I know what's going on. It's the namespace. Async demo. He has a API, like, okay. It's this class. He has this somewhere. Can I search? No. No. Alright, hold up. Let's just... I have to figure out how all this shit works, because I don't usually do it in C++, so I have to... Here it is. Knew I'd find it eventually. No. Save the level. I want to save it. Async testing. Couldn't find any good documentation on the fucking on this. This stuff is what I was talking about. Like, there's this whole control flow module. But it doesn't tell you how to use it. You know, that might be something coworker might know. Hey, what is the flow? Lost context on the conversation. Does it know? No, you have no idea. Okay, stop. It doesn't know. So hold up a second. So rather than trying to do this like this is good because it'll give me some stuff to go off of, and I actually want the one that I saw later in this video.
So, how do we add health? Well, one thing that we can do is actually select our health, make sure we compile so we can see our information on the right, and we can actually add a variable in here. So, we do this health, and then our boolean will be a float because that's what our lifetime is.
I don't know. I don't need this one. I need the other one. This one.
And welcome to the first episode of a new sporadic series that I'll be adding to every now and then. I know I said last time that I was...
Yeah.
So, with that disclaimer, the thread, since run, works.
Where's your promise?
However, when I stop it, we see one problem. It keeps running, even after the actor is fully destroyed. This is a memory leak, and it is not good.
Yeah,
Enough
we don't want
memory
that.
leaks, and you will tank the frame rate. Exactly the opposite of what we want. Now, why is this happening?
This
Even
dude
though we
is
set up a destructor
fucking copy and
since
set.
run never stops.
Set syntax,
Thread kill will
cadence.
never actually kill the thread, since run doesn't stop to check if it should stop. So we'll move on to step 2, how to prevent that while also adding a...
Yeah, I don't want step 1 if it's
this
not
new
working.
runnable will only run for a given number of times, and then it will stop. Plus, when I delete it in my actor, it will actually stop. As you can see, I'm using the variable bStop as a flag to actually stop run if it needs to be stopped early. Now, when I create the thread in my actor class, I just pass in the number of times I want it to run as an argument to the constructor. And if I stop the game, it cleans itself up nicely. Now for my complaints. Run should only be used to return the exit code of the runnable object. 0 means execution ran fully, and anything else should correspond to a different reason why execution ended quote-unquote improperly. If I wanted to do something a little more complicated than that, we're going to have to look beyond what we have right now, and this is where promises come in. Let's say I wanted to do some real hard math on my new thread, getting a list of all prime numbers from 2 through 10 million. Your first instinct as a programmer may be to just pass an array of ints by reference, but bear in mind, we are working asynchronously. I do not know when run will end, so if I use that array before run finishes, I won't get what I expect. Maybe if you've done a bit of multi-threading before, you're thinking callbacks. Listen, I've seen how messiness
No.
the callbacks can get, and I've written more than my fair share, so I will not be using those.
Even the
Instead,
observable
I use
pattern
promises. What's a
is,
promise?
which is what this is.
Promises, or futures, are programming patterns that lets you do something with the result of either regular or asynchronous code once it's ready, hence the name. Promises are not the result itself, but a promise that it will turn up eventually. If you're familiar with JavaScript, you've probably used promises before and really like them. I rarely praise JavaScript, but promises are so nice in it. But unfortunately, while Unreal Engine does provide them, they're not as nice as in JavaScript. So unless you want to program something better yourself, the out-of-the-box stuff is all we got. So how does a promise work? Well, just like with my fruntable examples, I've set up examples to show you. Here's a basic version. As you can see, we get the future that the promise promises. Then we can add a function that will run immediately after the promise resolves to a value. This function is called a continuation. And when I hook up and run this basic example, 4 is printed just as expected. Important to note with promises is that if you set the value more than once, you'll get a game crashing bug, which is really bad for the frame rate. The advantage of promises over callbacks is that I can chain these continuations without nesting them, so everything stays more easily readable. But again, not as nice as JavaScript. And for this example, it's important to note that even though I set the value of promise B before promise A, the result of promise A is still printed before promise B's result. So chained promises are good to use when you are waiting for the result of more than one asynchronous thingy or want execution to happen a fixed way regardless of resolution order. So for step 3 of the fruntable example, here's that prime number bad boy featuring promises. As you can see, at step 3, I am now deleting the promise in the exit function, since this function gets called after the thread fully finishes. After that, I just had to write a few more lines in my actor class to take advantage of promises. You could try deleting the promise in the continuation instead of in the exit function like we did in the chained promises example, but it'll cause some bugs, so don't. So when I run it, I have to wait a little bit, but ultimately it works. Then if I stop the game before it finishes, it cleans itself up nicely. And if we look at the FPS, hey, if it's good in the editor, it's better in game. Now this brings us to a design decision. I'm setting the promise value to an empty list if I stop the fruntable early. Now, to me, this is inappropriate. I'd much rather resolve to a different value specifying why execution stopped. So I created a wrapper to add that behavior on top of the resolution value. It's a lot easier than you'd think. I just hammered out the following lines. As you can see, it's super simple. Now I can set the promise's value to different resolution types to specify why execution ended. And since it's an enum, you could of course add more resolution types. And now the continuation function can have different behavior based on why the asynchronous code stopped. For this video, I kept it simple, but you should get creative and do whatever you want. And when I run it after waiting a bit, it works just as expected. And if I stop it early, it says so. And as a final piece of advice, if your code is crashing, you might have to add a minuscule sleep before setting the value of the promise. Asynchronous code is weird like that. I like to add a preprocessor directive so that way I can easily toggle it on or off if I need to. And that ought to do it for you. Keep in mind you can add extra methods to your fruntable subclass resolve to step 3.
All right, take that from the top.
So for step 3 of the f runnable example, here's that prime number bad boy featuring promises. As
I see. And it exit destructor constructor. Yeah, that's it. So destructor.
you can see,
Like, yeah, having to do the destructor like fucking throws me for a loop. For when I'm looking at it, I'm like, what is this? What is this shit right here? So that's the destructor, and I'm assuming it's the tilde right here, and then we've got the constructor. Frontable thread. So this is step 3. We can look at it. All right, sweet. No, not like that. Okay, and then no, fuck me. Okay, there we go. Where's the okay? Uh, yeah, that ain't right though. This is what I mean. It's just all fucked. Let me take a look at this. async future h. Not here. Let's go. All right, let's just take a look. All right, so delete this. Now it's going to be happy again. I'm going to try let's use the CLI to do it. Every time I try to fucking scaffold it myself, it just doesn't work at all. So let's have it add it through UE, and it'll scaffold everything out, and then I'll try starting to include the like multi-threaded shit. Okay. Now, I still want this stuff as examples. No, 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 no. Here. No, no, no. Here. Yes, there we go. There we go. Okay, so I don't understand how this works, but like the if def stuff, I don't understand. If def too fast. Let's just, I don't think we're going to be too fast. Just, we'll look into that and cross that bridge when we get to it. Take the simpler variant. Okay. Let me see version 2. Num times to run. It's not really how I want it to work. Let's look at the C++ for it. Damn. There's really nothing, huh? So what's this control flow stuff? There's the API that we were looking for earlier. Perfect. Okay, starting to get it. So I wouldn't do it quite like that. What I would do is now we can do this, for instance. And maybe get past some of these errors. Init, exit, run, stop. Alright, now, going back over here. Okay. I think I'm starting to see. So, yep. Excuse me. Okay, I think it deleted them, and then it's just a. Can I refresh? God damn it. This is how it usually goes when I try to do this. But Normally I just give up after a while and do it in a blueprint, and I can't do this in a blueprint, so now the persistence comes into play. Excuse me. Oh my goodness. Alright. So let's spin that up. Wait, no. Don't do that. Shit. Oh, come the hell on. Great. And blew it up. I'll go get some water. Hey, buddy. I'll be right back. Hey, buddy. You are here looking worried. Busy time. Oh, yeah. Oh, yeah, you gotta go to expression, yeah. All right. I think I'm beginning to get somewhere useful with this. So let's just go ahead and delete this again. All right, now one more time. Our base mode be a blueprint function library. It's going to be under. It's going to be. Ugh. I'm gonna have to manually clean up like the class structure and shit. That is super annoying. Okay. All right. Great. So, this I know. How do I expose a. Awesome. Okay. type.
In this video, we are going to learn how you can basically create a book. Hit to read. Let's wait in the at the first. Make sure you don't eat this why it's not declaring. Yeah, it's static. So once it's static, then we need to give the basically the string value. So let's give it that f str in the f string, then f string, then first bracket, and now because this is the f string, so we need to like this put, and once we put, as you can see, it have now a simple question like if you have f string, so the f string should be containing some of like data. What kind of data? Like if you want to input any data, okay, so that's why. So the add string, now we need to give this string data, but you can give name. Let's give it that happy, okay, and then as you can see, it's happy, or you can give it like text if you want. So I'm giving that text, okay. Now we, as you can see, it's showing a simple to create some stuff. So simply click on create define to text, but before that, because we are want to input, get input from user, like we can type manually, and then whatever we write, we want to display that. So for do that, we can add here a string that have a string as a string. So now we can declare that which type we create it as a string when getting input. So what you can give it name. So let's give it name, name. Okay, I'm just writing that. Yeah, it's name. Then simply click on create definition to text or whatever we create in our CT header file. So it will be create a, it will be automatically write code for us. So it will be take some time, but it will be do the automatically when we can do it manually, and it will also display in our header file. So it will be more easy to navigate and easy. Doesn't matter if you don't want, we can write manually. So now we want that whatever I write here, like in my name, this is a variable kind of like you can call it a string variable. So want that in my return that it should be displayed. So let's call that name. Okay, so now I have everything. Click on simply save. Now let's go to our Unreal Engine. Where is that? Here. And simply here, the compiler button is now at here. So simply click on compile. Okay, so our code has been successfully right. So now let's go to an begin page and let's search our code that printf or print copy because we gave it name. Oh, okay, that is basically come in the tag. So here's our name and return value. So let's give the name is Sujat, and if I connect it with this and get a print string and compile and save. Oh, I don't need to save that. If compile, it will be work. So play. As you can see, it's printing the subject. So that's all. I hope you understand, and thank you so much for watching. See you in the next tutorial video. For play my game, you can check my Google Store account, and you can follow me on my Facebook page. Also, you can visit our website for get more information. And if you have personal project or if you have some work, you can Gmail me at my Gmail address. Also, like, share, and subscribe and support me. If you want my paid course, you can check in YouTube.
Okay. Da, 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 da. Maybe I'm just declaring the fucking array wrong. Probably has to be. Is it like this? What's the fucking pass by reference thing? Pass array to. Coworker. Actually, I should really be using coworker for this. How do I declare an array of... Yeah, see, totally missing it out. And that's the reason why it wasn't working. Nice. Okay. Oh, this is. Okay. This is interesting. So, if I wanted to redo all this as C++, this would generate the header files. Will it generate the C++ files? Doesn't appear to. But this is actually useful. Um, okay. Okay. We're learning. Multi-node data. You kidding me? You don't even give me the includes? Man, come on. U property. Where's the other one? That could be better. Like, how hard would it be to just include the includes? See, like, why does this not work, you know? Is there a good way for it to, like, auto-include this shit? Because... I'm thinking... Let's get coworker on the case. Hmm. All right, back to square one. Maybe I can't do that if I'm running this. Okay, so let's try something with the help of coworker. Alright, well, I gotta hop off for a bit. I'm gonna continue grinding this over the next few days. I gotta go take care of some shit around the house. Later.